Good morning, students. Welcome back to science class on the chapter work and energy. In the previous class, we had started and we had studied what is work done. Okay, or when do we say that work done? Right? If an object, suppose if you apply a force on an object, if that object covers some displacement, so then we can say that work is done. Okay, so to calculate that work done, we had studied the formula, that is W is equals to force into displacement. Here W represents the work done and force represents, F represents the force and S represents the displacement. Okay, when you multiply that applied force and the displacement covered by that object, so then you will get the work done. Okay, if anyone see, if you want to say work done, if out of these two, if any one of the conditions, whether the applied force or displacement, okay, doesn't exist, then we can say that work is not done. Okay, for example, suppose we apply force on this wall. If the wall, if it doesn't change, if it doesn't change its position, or if it doesn't displace its position, so then we can say that work is not done. Okay, yes, this thing we have discussed in the previous class. Also, we have discussed two problems related to this one, and the essence of work done is joules. Okay, so Newton meter or joules. So usually we use joules. So already also we have studied, right, what is the meaning of 1 joule. If the applied force, if we apply 1 Newton force, if the object displaces for 1 meter, 1 meter, then we can say that 1 joule of work is done. Okay, yes. So now today we shall study energy. Yes, life is impossible without energy, correct? Yes, already you know what is the importance of energy. Yes, sir. The demand for energy is ever increasing, correct, day by day. Why? Because due to the population, even population is also going to increasing day by day. So that's why the demand for energy is also increasing day by day. Because we have to say, we have supply to energy to everyone, right? For example, take which one, electrical energy. We should supply current for every home, correct? So that's why the demand for energy is, it is increasing day by day. Next, yes, sir. If you want to do a work, so you need energy. Without energy, you can't. Okay. For example, take a fast moving cricket ball. Okay, a fast moving cricket ball, it hits the stumps. What will happen? The stumps, they'll thrown away. Why? Because that ball, so it is moving, which means it will apply force on that wicket. Okay, then wickets are thrown away. Why? Because here, while moving that ball, it carries some amount of energy. Okay, see, without energy you can't apply a force. If you want to apply a force on object, then you need energy. So without energy you can't apply any force, and without energy you can't do any work. Okay, for example, the raised hammer. Okay, just imagine, take one nail. Okay, if you want to drive into the wall, then you have to use a hammer, right? So you have to bring that hammer from a certain distance, correct? Okay, that raised hammer. So now see, for example, say this is hammer. If you hit like this, it won't rise into the wall, right? Why? Because you have to bring this hammer from here, which means that raised hammer, we can say that raised hammer, it has a capacity to do work. Okay, the raised hammer, it has capacity to do work. And take a balloon, just to blow it. Okay, if you press that balloon, what will happen? You can observe the change in the shape of that balloon. If you press gently, what will happen? It produces a sound and it blasts, right? Correct. So when you press like this, which means at that time, your hands, okay, it has a capacity to do work. uh, then you take a fast cricket moving fast cricket ball. Even say it when it hits the stumps are well still thrown away, right? Why? Because that ball at that time, that ball it has a capacity to do work. Okay, see here the energy means the capacity for doing work. Okay, the capacity for doing work is known as energy. Okay, see in energy there are different forms are there. Okay, first one mechanical energy and electrical energy, chemical energy, then nuclear energy. Okay, etc. Okay, these are the energy forms. This year you are going to study only two energies, that is kinetic energy and potential energy. See, kinetic energy plus potential energy together we call, that is mechanical energy. Okay, so mechanical energy means some kind of physical environment. Okay, so mechanical energy means kinetic energy plus potential energy. Okay, so clear, right? What is energy? So energy is nothing but it is a capacity for doing work. If you want to do that work, you need capacity. Right? Capacity that comes from energy. Okay, so energy means it is a capacity for doing work. See here, for example, work done. So work done is equals to what? Force into displacement. Okay, force into displacement. See here, I will apply force on this object. It displaces its position. It covers some displacement. So then you can calculate work done. Why? Because here I have applied force on this object. So that's why work is done. Okay. See that work is done because of energy, right? Correct? Because you will apply a force. If you want to apply force, then you need energy. So your entire energy is expressed in terms of work done. Clear? So that's why we can say that work done is equal. Sorry, energy is equal to work done. Why? Because here that energy it is expressed in terms of work done. Okay, so work done is also equal. Energy is also equal to work done because that entire energy it is converted into work done, right? Correct. See now my hand. See now I have capacity, so I can hit this marker, which means here I am applying a force. Why? Because I have energy. When you apply a force, so work is done. Correct. So that energy is converted into work done. So that's why energy is equal to work done. Okay. So now we measure, so that energy is equal to work done, right? So that's why we measure energy also in joules, means we use joules to measure the energy. Okay, so SI unit of energy is also joule. Okay, yes. So now first we shall study kinetic energy. See, in the previous year we had studied energy chapter. Okay, about kinetic energy. Kinetic energy. Okay, yes sir. Tell me what is the kinetic energy. Okay, yes, put the answer in the comment box. I'll wait. What is kinetic energy? Okay, quick. What is kinetic energy? Yes, I am waiting for your answer. Tell me what is kinetic energy. In ancient you had studied, right, about kinetic energy. Fast. So energy means what? It is a capacity for doing work. Then what is kinetic energy? Yes, the energy possessed due to the motion of an object is called kinetic energy. Correct? Yes. Next, Nagar. No. Okay. Okay. Yes, the energy that the body possesses due to its motion. Correct? Next, Sharanu Saukar, the energy possessed by a body due to its motion is called kinetic energy. Very good. The energy possessed due to its motion. Yes, already you know, right? So, what is kinetic energy? Just a minute. See it. Listen here. Okay. See, take that cricket ball, correct? That fast moving cricket ball, it hits the stumps. Okay, the stumps they will displace us, right? So here we can say that that ball, that moving ball, it has a capacity to do work. So that ball is that ball is gained energy. Why? Due to its motion. Okay. See now, just imagine. Say this is a marker and this is a duster, so just I will keep here. Do you think that is there any work is done here? Is there any work is going to be done here? No, right? See, when you throw this duster, okay, when you throw this duster, then only this marker it displaces its position. If you keep like this simply, okay, it this marker it won't displace its position, right? But if you throw like this, okay, at that time this marker displaces its position. Why? Because see here, while moving this duster, it has a capacity to do work. Okay. Then take one example, that which one, flowing water. Okay, flowing water. So in that path, just put one object. That object will move along with that water, right? Why? Because while moving that water it is in motion, right? So that's why that water it possesses energy. Okay. So now clearly we can say that when the objects are in motion, they will gain some kind of energy, or they will possess some kind of energy. Just imagine, your friend is simply standing here. You will come with some amount of velocity. You are coming with some speed. If you collide with your friend, what will happen? It may hurt, right? See, both will fall down, correct? Or in our case, just simply stand with your friend. At that time there is no injury, right? Both of you won't fall down. Why? Because you are simply standing. But when you come from a certain distance with some speed, because you are in motion, so that's why you will possess some energy. Okay. So now the kinetic energy means, if the objects possesses energy, if the objects possesses energy due to its motion, or when the objects are in motion, they possesses energy. Okay, that energy is called kinetic energy. Okay. So what is kinetic energy? So kinetic energy means, when the objects are in motion, they possesses energy, so that energy is called kinetic energy. Okay. uh, Okay. Yes. So see here. So now give some examples for kinetic energy, when the objects they possesses kinetic energy. Give some examples. Okay. I'll give an example. Flowing water, it possesses kinetic energy. Now give some examples. Give some examples for kinetic energy. Quick. Yes. So wind. Then arrow released from the bow. Correct. Then fast arrow released from the bow. So that is also example for, sorry, that arrow it possesses kinetic energy. Why? Because that arrow it is in motion. So that's why it possesses energy. Then Yes, flying aeroplane, correct. Bullet from the gun, good. Yes, these all possesses kinetic energy. So clear it. What is kinetic energy? So when the if an object possesses energy due to its motion, okay. So then we can say that is kinetic energy. Okay. So examples already discussed, right? You know, a falling coconut, then a speeding car, a rolling stone, a flying aircraft, flowing water, blowing wind, a running athlete, etc. Okay, so kinetic energy is possessed by an object due to its motion. Okay, so clear it what is kinetic energy. For example, now take one more example. Consider two objects. This is object A and object B. Okay, so this object is moving with say 10 meter per second. Now just when this object is moving with 10 meter per second. Now this object B is also moving, but its speed is or its velocity is 20 meter per second. Okay, so object A is moving with 10 meter per second and object B is moving with 20 meter per second. Okay, so both these two are velocities. So now tell me, both, just imagine both are in motion. Object A is moving with velocity that is 10 meter per second and object B is moving with velocity that is 20 meter per second. Both are in motion. So now tell me which object. So now clearly we can say that both the objects possesses kinetic energy. Why? Because both are in motion. So now tell me which object possesses more energy, more kinetic energy, A or B? Quick. Yes, here Channu, but yes, you are told option B. Tell me why that object possesses more energy. Now say mass of this object is 3 kg and its mass also 3 kg. Okay? Yes. Mass of object A is also 3 kg, mass of object B is also 3 kg, but the velocities are different. Tell me why that object B possesses more energy. Yes, you know, right? There is a difference is right. You know, take a bullet, take that bullet and throw it to your friend body. It won't hurt, but yeah, if you use that instead of your hand, if you use that pistol, okay, the bullet from the pistol, it may kill your friend, right? Why? Because at that time, that bullet from a gun, it moves with a huge amount of velocity, correct? So that's why if the velocity is more, then it possesses more energy. So here body B which possesses more kinetic energy. Okay, now next see object A and object B both are moving with same velocity, both are moving with same velocity. Okay, so but the mass of the object A is 6 kg and mass of the object B is 3 kg. Now tell me here, both are moving. So now out of these two, which object possesses more kinetic energy? Yes, object A. Why? Give me the reason. See, earlier you are told, right, more velocity. If the velocity is more, then kinetic energy is also more. So now velocities are same. How do you say that object A possesses more energy? Yes, because it has more mass. Okay, you know. For example, take one plastic ball. Okay, just to throw into your body with cement. Instead of that plastic ball, take one stone. Okay, throw it to your body, throw it to your friend's body. There is a difference, is there, right? So that stone, it may hurt your friend. So that's why if the mass is more, if the mass is more, then kinetic energy also more. Okay, yes. So now see here. Okay, here we have discovered how to calculate the kinetic energy. For kinetic energy, earlier in we have discussed the previous example. In that case, object B possesses more energy. But how to calculate that kinetic energy? Yes, you have studied, right? In your standard, you have studied the formula to calculate the kinetic energy. Yes, what is the formula to calculate kinetic energy? What is the formula? Yes. So half into mv square. Why we are using only mv square? Because see, kinetic energy, whether it increases or decreases, kinetic energy depends on mass of an object and velocity of the object, right? Okay. See, kinetic energy means what? It is the energy possessed by an object due to its motion. Due to its motion. When the motion means here that object it has mass, right? And while motion in motion it has velocity. So if you increase the mass or if you increase the velocity, then the kinetic energy changes. So that's why kinetic energy, which depends on mass and velocity. So we can relate kinetic energy, mass and velocity. So using this formula, that is kinetic energy is equal to half mv square. So in your standard you have studied, right? So this year you are going to prove this one. Okay, this kinetic energy is equals to half mv square. Okay. So already we have discussed what the energy, we express energy in terms of work done. So energy is nothing but it is equal to work done. So that's why here also we can say that take that the fast cricket moving ball, it is moving, so it possesses kinetic energy. It collides with the stumps, right? So what will happen? So that ball it will apply force on those stumps. So we can say that work is done. Okay, so this energy is converted into work done, right? So that's why here also what kinetic energy is equal to work done. Okay, keep in your mind. So kinetic what energy is equals to work done, means we'll express that energy in terms of work done. Here which energy? This kinetic energy. So that's why kinetic energy is equal to work done. Okay. Okay. So now on the in the tomorrow class we will discuss what we can we'll prove kinetic energy is equals to half mv square. Okay. Next energy. Yes, if you have any doubts in kinetic energy, please ask. Okay. Someone said, okay, bye, sir. Class is not over. Just I have told in the next class we will derive that kinetic energy equal to half mv square. Okay. Yes, sir. If you have any doubts in potential kinetic energy, please ask. Okay. If you have any doubts, please ask. Okay. Sir, can you explain shortly? Anupama Devi. What? Can you explain? Can you explain shortly what? No. Yes, can you explain shortly? Tell me what? What is that? What should I explain shortly? Yes. Okay. See here. Next, move to potential energy. Okay. Yes. Sir. So now tell me what is potential energy. So in the previous year we had also you had studied about potential energy, right? So tell me what is potential energy. The energy possessed due to its position or deformation is called potential energy. Yes, correct. Yes. Wow, very quick answer. The energy which a body possesses either due to its position. Okay, then possessed body due to its position is called potential energy, correct? The energy that the body possesses due to its position, correct? The energy that body possesses due to its position, yes, good, okay, yes. Now see here, what is potential energy? You know, mm, so I'll take this duster, okay, see here, see, I'll see now here, see, I have raised this duster up to here, okay, see, if I now I will drop this one. See here you have heard some sound, right? Okay. So now tell me, here we have heard that sound. Why? Because some work is happened. Okay, some work is done. Clear? See, you heard that sound. Why? That is because of you have raised this duster from a certain height. If you simply keep that over the ground, do you hear any kind of sound? No, right? When you drop that object, or when you drop that duster from a certain height, then only you can hear the sound. Okay, so now we can say that that now this duster raised to a certain height, right? So you are dropping this duster from this point. See, you can take here or here, but sound it will come, right? If you drop this from here at this position, now this duster, it has a capacity to do work. Clear? See, you can hear that sound when you drop that duster when you drop that object from a certain height, then only you can hear the sound, otherwise you can't. Clear? Take other examples. Stretched arrow, correct? See, when that arrow moves, see, if you hold simply like this, do you think that that arrow will move? That arrow will move? No, right? When you stretch that arrow like this, when you release that arrow, then only it will move with some huge amount of velocity. If you simply hold like this, without the stretch, that if you simply hold like this, then it won't move, right? So when you hold that arrow at this position, it has a capacity to do work, right? Correct? So at that position, it has a capacity to do work. Correct? And see, when that water it will move with a huge amount of velocity. When the water is a drop, when the water is falls from a certain height. Correct? When it falls from a certain height, at that height, that water it has a capacity to do work. Take one dam. Okay, so we can store the water in a dam, right? When you open one gate, what will happen? That water it will come with a huge amount of velocity, right? Correct? So when you open the gate, that water it comes or it moves with a huge amount of velocity. If you place on any object, then that object also it moves along with that water. Okay? Why that water is moving? Because here we have stored that water here. Correct? Clear? So that's why that water is moving. Okay, so now the water stored in a dam, at that time that water it has a capacity to do work. That raised hammer. If you want to drive the nail into the wall, you have to raise that hammer, right? You have to bring that hammer from here. At this position, we can say that hammer it has a capacity to do work. Correct? So potential energy means the energy possessed by an object, due to its position. Okay, the energy possessed by an object due to its position is called potential energy. Okay. So now take one stone here. Okay, so now if you drop one stone from this height, from this position, okay, so now it will fall down with a huge amount of velocity, right? It will come with a huge amount of velocity. But if you drop this stone from here, okay, here the velocity is very less, but here the velocity is, when you drop the object from here, in this case the velocity is more. Why? Because you are dropping this ball from a certain height. Okay. So now the potential energy means what? The energy possessed. The energy possessed by an object due to its position is called potential energy. So example for potential energy: one water stored in a dam, stretched arrow. Then hmm, other examples. The stone on the mountain. Okay, so these are all are example for potential. And a compressed spring. Compressed spring, right, in a bike car, correct? Do like this, that key, right? So instead, what will happen in spring? It will compress, correct? If you wind that key, that car will move, right? So inside that which one? That chain, it is compressed. That spring, it is compressed, right? So that compressed spring, it has a capacity to do work. Work means what? That car will move. Okay. Yes, a child at the top of the, what is that? Still day. No, next that, yes, sir. That catapult, correct? Right? Catapult, correct? So here we use one thread, and here we will keep one stone. I think you have played that one, right? Then a stretched rubber band. Stretched rubber band is also example for potential energy. Okay. Now you can ask, see, earlier we had studied what, when the objects are in motion, they will possess kinetic energy, correct? When you drop this stone here from here, so here I am saying at this position it possesses potential energy. When you drop, it will move, right? It will move, means that object it is in motion. At that time it possesses kinetic energy, right? So which one is correct? See here, both are correct. In motion, it possesses kinetic energy, right? But at this position, here that object possesses potential energy. So which one we should use? Either potential or kinetic energy? Here possesses kinetic energy. So here also that potential energy is converting into kinetic energy. Okay. So now tell me how to calculate potential energy. See here, take two objects. Okay, so one I will drop from here. So I will drop two objects from here, same height. So object A and object B. Now its mass is say 10 kg and its mass is 2 kg. So now tell me which objects gain more. So you will drop from here and here. So now tell me, out of these two, which objects possess more energy? Sorry, more potential energy. More potential energy. Quick. Object A or object B? Yes, object A. Why? Because it possesses more energy. So that's why we can say that the potential energy, it depends, potential energy, it depends mass. So if the mass is more, then it possesses more potential energy. Okay. Next, see here. So one, consider two objects, 3 kg, and one more object B is also 3 kg. Okay. Now I will drop this object from 10-meter height. Then I will drop one object 5-meter height. So now tell me which object possesses more energy? Object A or object B? Yes, clearly we can say that object A. Right? I will take one short put. Okay. See, you are holding here, and I will drop that short put see here, from this height. Okay, very short height. The distance is the height is very less. Then I will tell you, just stand over the ground. I will drop that short put from 2-floor buildings from the top of that building. At that time, you can't catch that short put, right? But see, if I draw from this height, you can easily catch that one. Okay, it hurts, but very less. But if I tell you, just stand over the land and I'll drop that shot from the top of the building, three floors building. At that time, you can't, right? Why? Because when you drop from the top of that building, at that time, that shot put possesses more energy. while dropping from this height, at that time it possesses less energy. So we can say that when you increase the height, what will happen? The potential energy increases. So we can say that potential energy, it also depends on height. Okay. See here, why it depends on the height? If you increase the height, potential is more, right? Why? Why? Because while falling down, what its speed increases, right? Why? Because that is due to the gravitational force. So that's why here we call that when you drop the objects from a certain height. Okay, so at that time we use gravity. Those objects possesses energy. Which energy? Gravitational potential energy. So now, if you want to calculate potential energy, we use this formula, that is m into g into h. Okay, so m into g into h. Here m means mass of the object and g is the acceleration due to gravity. Okay, see, if you just drop the objects are falling down. Why? Due to the gravity, right? So earth it attracts, so due to the gravitational force. So that's why we use g. And it depends on the height, right? When you drop the object from a certain height, at that height object possesses more energy. Okay, see, actually this is a gravitational potential energy. This is the expression m into g into h. That is, it is actually gravitational potential energy. Okay, so in the next class, once again we are going to derive this one. So potential energy is equals to mass into acceleration into height. Okay, so we use this formula to calculate potential energy. Okay, don't miss next class. In the next class, we are going to derive first one. Kinetic energy is equals to half into mv square, and potential energy is equals to m into g into h. Okay, sorry, yes. The next class will derive these two equations, these two derivations. Okay, I will stop here. Tomorrow I will continue the class. Thank you.